All right. Now we're going to simplify this expression, and it just comes down to factor it and see if there are any common factors. Very simple if you can factor, right? And people seem to do pretty well with the factoring. At least, you know, everybody made at least 85% on the homework. Okay. And oh, Alex, you sent me a question last week sometime, and I finally answered it last night. So just check. It was just simple. If you square -2, you get +4. So yeah, everything looked really good. Okay, so here we have I could write that as x minus 6 squared, but we just want to think x minus 6 times x minus 6. So that we only divide one of these into this one, right? Now, when I write this out, I say this equals then equals this, okay? Because of cancellation again. People will not learn cancellation, okay? There are rules, but for some reason, people don't do well with those rules. So I don't like to use it. I like to go back to the basics here. This equals this, why? Because if you multiply the numerators and multiply the denominators, this is what you get, right? So we're just separating it out into a fraction and a fraction, or a rational expression and a rational expression, right? That still multiply out to this, but now we've got something divided by itself, so that's just 1. Okay. Yeah, we've got a question. People will then cross out the x's and tell me we got -5/6. Okay? Why I don't like cancellation. Okay? Okay, you get your x plus 5 over x minus 6. Well, there's an x and there's an x. So now we have 5 over -6, which is -5/6. Okay? Now, why doesn't that work? Do you understand why that doesn't work? Or do you just understand that it doesn't work? If you don't understand why it doesn't work, then you don't really understand the rules for cancellation, and very few people do. Very few people in a pre-calculus course do. I see this stuff all the time. There's no way I've ever found to stamp it out. People just cross things out. People see an X here, they see an X in 5 pages later, and they cross them out. Well, it doesn't go that bad because nobody remembers what they saw 5 pages before. But you understand what I mean? Okay? Or they'll see this X and this X and this X and this X, and they'll cross them all out, and they'll end up with -6 times 5 over -6 times 6. Okay? What I always put on a pretest is x plus 4 over x. Okay, 90% of students in a pre-test on pre-calculus will cross out the X's and tell me they've got 4. All right, we can't teach mathematics to people who don't understand the rules of cancellation, which are taught very thoroughly in algebra course, okay? And I'm not back there circulating. I don't really need the mask. It's probably not a bad idea. Okay. Cases go up just a little more. They went up last week. Okay, but so there's a reason I do this, and a reason I'm very unsympathetic if you just cross things out wrong. You know, the whole problem's going to be wrong even if you did it all right. Okay, it's one thing I won't tolerate. Not that I'm going to be mad at you, but it's, you know, I'm not going to give credit if I see incorrect cancellations. And another thing is you got to check your results. Okay. Now, one way of checking this result, this has to be true for any value of X at all, right? So pick a number. Not a real simple number like 4.7. Take your calculator and figure this out, and figure out what the decimal is. Okay? Take your calculator and figure this out for X equals 4.7. See if you get the same thing. Okay? I picked 4.7 because you could accidentally pick like -5 or 6. Okay? 6 wouldn't be good at all because your denominator would be 0. You get something from the value, right? Okay. And so you could accidentally pick a bad number, say 79. Okay. And use your calculator because I don't want you to have to square 79 and stuff like that. But if you use your calculator, it's very easy to do it, and you'll see if you did it right or not. And this is another thing that I really encourage people to do. I know people under time pressure, everybody's under time pressure, okay? If you have any kind of life, you got time pressure, okay? So if you don't have time pressure, I feel bad for you because you don't have much of a life. Well, not really, okay? Hopefully you can eliminate most of the time pressure, but everybody's under time pressure. So people skip the step of checking their answers, the results, okay? So you don't get immediate feedback on whether you did it right or not, so you just go on and likely move on to the next thing and make the same mistake again, keep making it, okay? You gotta check your results. It's part of the process. Now, if you don't check every result, at least check the ones where you think it's most likely you're making a mistake. You get feedback in open math on whether you got it right or not. If it's something you tend not to get right, that's where you got to start checking. And of course, on a test, I don't put a time limit in the test. I want you to have plenty of time to check, right? Okay, so anyhow, down here, okay, 3x plus 7 equals 5x minus 2. I'll add 2 to both sides, okay? That gives me 3x plus 9 equals 5x. Well, I still got x's on both sides, right? I chose to add 2 to both sides, so my x's are going to end up over on this side. So usually I do the x's first. A lot of people do it this way. It's perfectly all right. So I'm going to subtract 5x. No, I'm not. just said something I should have paid attention to. Okay. I think I wrote something down wrong there. I think I wrote down -9. We're going to subtract 3x from both sides. And that's going to give us 6x equals, going to give us 9 equals 2x. Checking myself. Okay. It's been a strange morning. Okay. So what do we do now? Well, we want to get x. We divide both sides by 2 because this gives us this, right? So 2 over 2 is 1. X over 1 is x. And x equals 9/2. Now, you might not want to go to the trouble of writing out this stuff every time. You ought to write it out once in a while to remind yourself of why you don't subtract that 2. If you subtract that 2, this common error. Okay. 2x minus 2 equals x, no. Okay. And if you did this, you take that 7 and you plug it back in here. 3 times 7 is 21. Add 7, you get 28. 5 times 7 is 35. Subtract 2, you get 33. So if x is 7, you get 28 here and 33 here. They're not equal. Now, if x is 9/2, 3 times 9/2 is 27/2. Okay. 5 times 9/2 is 45/2. Okay. Well, 7 is 14/2. 27/2 and 7/2. Okay. Is 41/2. And 45/2 minus 4/2, which is -2, is 41/2. No, you probably can't do that in your head. Okay. If you can, great. But if you write it out, it's not difficult. Okay. So be careful about that. Okay. Well, now solve for b here. Okay. So AB plus Q equals R. Yep. Well, we want to solve for B. A little circle around it. Subtract Q from both sides, and the Q's go away. So now you have A times B equals R minus Q. Now you don't write minus A B equals R minus Q minus A. That's totally wrong. Shouldn't cross out the A times B. So you get AB over A equals R minus Q over A, right? And you can write this as A over A times B over 1 equals R minus Q over A. And that's just 1 times B over 1 and so forth, so that B equals R minus Q over A. Doing the same steps you would if there were numbers here, but now there are variables, okay? Now I saw a lot of these errors on the quiz, the test. So you really need to maybe go back to, let me double check what the section is. This thing zoomed on me again, didn't it? And that's probably a good thing because I wouldn't have the whole board. So it was smarter than I was this time. Okay. We gotta show the pretty picture to get focus. Picture there. Okay. Just for people that happen to be watching the video. Have things in focus. All right. Okay. So we've got these two problems. Okay, 5 7s. Plus 3 4. We want to do all the steps the way we did it at the very beginning of the course. Okay. Multiply 5 7s by 4 over 4, which gives us a denominator of 28. Now, first thing you notice, your common denominator is 28. And I think everybody noticed that. I'm just reviewing what we should know. And if you don't, go back to that first assignment of adding fractions, okay? Then work through it, especially after I go through there and allow you to practice afterwards. I thought they were all set up that way, but apparently some aren't, so I have to check it. Okay, or go to the late assignments page to do it, okay? You don't have to do it on open math, just work it out. See what they tell you. How you get 20 over 28 plus 21 over 28. That equals 20 plus 1 over 28. Why don't we have 28 plus 28 down here? Because of the distributive law. This means 20 divided by 28 plus 21 divided by 28. Okay? So if you had 28 plus 28 down here, you'd have 56, and it wouldn't be the same as this. You want to try to understand that as best you can. So you have 41 over 28. 41's prime, doesn't factor, so you're done. Okay? Now, that board still. Okay, so anyhow, what's that equal? Well, your common denominator is 4x, right? 7x, sorry. Okay. So you're going to have a 7x down here if you want to add these, because you have to have the same denominator to add them. That's because of the distributive law. Down here, we had the same denominator, so this was the same as this. Because this means, again, this divided by this, which is this divided by this, which is this. Okay? So to get the common denominator, 7x, we'll just identify common denominator 7x. So x plus 3 over 7 has to be multiplied by x over x. That'll give us a 7x in the denominator. So now you got 4 over x times 7 over 7. And now we multiply this out. That's numerator times numerator, denominator times denominator. Multiplication is easy. Addition and subtraction is where you got to do the common denominator and make sure everything follows the rules. It's plus 1 equals. Writing out a little more detail maybe than necessary, but it's not a bad idea. Okay, so that gives us x squared plus 3x over 7x. And this gives us 28 over 7x, which then equals 4. I don't know where I got 4 out of this. Equals yes. I mean, the rule is you can add the numerators if you got the same denominator. If you understand why the rule works, it's because of the distributive law. Because applying the distributive law to this, I've got x squared over 7x, 3x over 7x, 28 over 7x, right? And the x squared over 7x and 3x over 7x is the same as x squared plus 3x over 7x and all that. You want to think that through. Not a bad idea. If you don't think you're going to totally remember that, you go back and look at the video where I pointed that out. You know, how far are we into the video? 15 minutes maybe? Wouldn't be hard to find that. Go a little ahead of that, come back to where I'm talking about it. So sometimes it's worth taking the time. That's an important idea. The fact that all we're doing is really, we're just kind of taking a factored form using the distributive law, okay? So I'll construct the complex sentence it would take to say that, but it's just distributive law. And you want to try to see that in the expressions. Okay, so let me give you another one, and also now, we want to see if this factors, if this simplifies. Because it's possible the way these things go together, that maybe this numerator factors, maybe there's something in the denominator that matches that factor, okay? But if you try to do this, well, you can check the discriminant. It's not going to factor, okay? 28 is too big. Any pair of factors you get for 28 is going to give you a lot more than 3x. Eventually, if you do enough practice, you start to see that. Okay. Let's try. Okay, x squared plus 5x plus 6 over x squared plus x minus 6 plus this. Okay. And that should work out kind of nicely if I did it right in my head. Whether it does or not, process is the same. Okay, just give a hint. The hint was factor these first. Okay, Otherwise, it gets a little messy and a little bit hard to factor. Okay, working this out, we're recording. We've got a lot of good steps people are making, but everybody messed something up. Okay, so if you mess something up, you're not alone. Let's try to fix it. Okay, so, and it's a little complicated, and we haven't done this. I think this is due next time. X squared plus 5x plus 6 is x plus 3 times x plus 2. X squared plus x minus 6 is x minus 2 times x plus 3. And nothing factors over here, obviously. Okay. Well, now we've recognized that we have an x plus 3 here and an x plus 3 here. And we want to take advantage of that because now we can write this as x plus 3 over x plus 3 times x plus 2 over x minus 2. And then over here we got x minus 2 over x plus 3. Then x plus 3 over x plus 3 is just 1. I don't want to cross anything out. If you do, okay, as long as you do it right. But I say don't do it. Make that into 1. So you understand what's going on. You're not doing something magical. You're not crossing stuff out. You're getting a 1 that's multiplied by something. That's what cancellation really is. Other rules, you can cancel common factors, okay? That's about the only thing you can cancel. And those are common factors. So if you really know that rule and don't forget it, it's okay. But if you do it like this, you're going to see it. Better than memorizing a rule that doesn't make sense to you, okay? And that is easily misapplied, okay. So we have this. Okay, now we have a common denominator. X minus 2 times x plus 3. What are we going to do to get the common denominator here? Okay, let me toss this out and let you think about it and see if you can see what to do. Okay, now remember what we did back here. This step that I see a lot of people skipping when they do fractions, even though I've urged you from the beginning, not getting on you, but just, you know, from the beginning of the semester, beginning of the course. I urge you to write this and this, right? You don't just skip the step and do it in your head or something, okay? Because you have to understand what's going on. If you got 5 7s plus 3 4s, you got to have a denominator of 28 in order to add these, or some multiple of 28. You have to have the same denominator. What do you have to do to get a denominator of 28, okay? And of course, I didn't bother observing that the common denominator is 4 times 7, which is 28, right? Because that's a common multiple of these two numbers. And I think everybody understands that, okay? So I multiply, what do I have to multiply 7 by to get 28? Well, obviously 4, right? So I do 7 times 4 in the denominator, but I can't just do 7 times 4 in the denominator. That would change the value of the fraction. But if I do 7 times 4 here and 5 times 4 up here. If I multiply both the numerator and denominator by 4, I don't change the value of the fraction. I get 20 over 28, which reduces back to 5 over 7 if you want to reduce it. Okay, so I multiply both the numerator and denominator by the same number because that is just a multiplication by 1. 4 over 4 is 1. So multiply 5 sevens by 1. I haven't changed the value. Okay, there's several ways to see that this is the same as this. And I multiply this by 7 over 7. Now, what do I have to do down here to make both denominators x minus 2 times x plus 3? Well, I have to have x plus 2 over x minus 2 multiplied by something over itself. I have to multiply by 1. What do I have to multiply by in order to make the denominator x minus 2 times x plus 3? Then I've got x minus 2 over x plus 3 multiplied by something over something. Can you fill in that set of parentheses? Okay. Now we get down to here, and we want our denominators to both be this. Okay. So this term is going to have a denominator. Now, just like we multiplied by 4 over 4 or 7 over 7, or over here, we multiply by x over x, we multiply by 7 over 7, right? In every case, what we multiplied by had the same numerator as denominator because that doesn't change the value of the expression because we're just multiplying by 1. Okay. Now, what I multiplied by up here, I had to get a common denominator 7x. Okay. Well, I had 7, so I have to multiply that by x to get a denominator of 7x. So I have to multiply that 7 by x, which means what I multiply by here, since it has to have the same numerator as denominator, has to be x over x. Here, I had x in the denominator. I wanted to get the common denominator 7x, so I multiplied by 7 over 7. Because the 7 times the x gives me 7x, and because this has to be the same as this to make this 1. So over here, I have to multiply by something that will give me this denominator, x plus 2, x minus 2 times x plus 3. What I have to multiply x minus 2 by to get x minus 2 times x plus 3? Well, I have to multiply x minus 2 by x plus 3, don't I? And now I'm going to have the same denominator. Well, I can't just multiply the denominator by x plus 3. I'm not done because that would change the whole fraction if I didn't multiply by 1, which in this case I write as x plus 3 over x plus 3. And now, if we look here, I've got x plus 3. I've got to multiply that by something over here that gives me x minus 2 times x plus 3, right? So I got to multiply by what's missing. I've got to multiply by the x minus 2. And then the numerator also has to be x minus 2 again, so that I don't change the value of the fraction. So I've just multiplied this fraction by 1 but in this form, and I multiplied this fraction by 1 in this form. Okay. So that gives me, write it over here where I've got a little room. This, just multiply the numerators. once you see it, you get it. Yeah, okay. And this gives you then x squared plus 5x plus 6 over x minus 2 times x plus 3 plus x squared minus 4x plus 4 over x plus 3 times x minus 2, which is of course the same as x minus 2 times x plus 3. So now I can add the numerators. Okay. I add the numerators, and I have this over the denominator, which is the same as this, right? Plus this over the denominator, same as this. Okay. We need to put parentheses around these to emphasize the fact that I've still got this here because of the distributive law. Okay, well, I'm out of room and we're out of time. If you need to leave, just go around the back. I'll walk in front of the camera. And because I don't want anybody to miss the sight of me. No, that's not it. That'll be their advantage. Okay, I add these. And this gives me 2x squared plus x plus 10 over x minus 2 times x plus 3. You want to do this because then you factor this, if possible, which probably isn't. Okay, as a matter of fact, I know it isn't. Again, the 2 and the 10 are too big. But if this factors, as some of the problems will in your assignment, then some of those factors might match 1 or 2 of these, right? And you could still reduce it even further. So it's kind of an adventure working through one of these. Open Math will show you. They'll do a lot of cancellation, but try to understand why that works, okay?